connection. So in terms of design still, we look at the system size and the possibility of tilting and orientation, and the dimension, as I say, related to the size, the energies to be stored, but also the possibility of integration in the grid system, but also environmental factors. In terms of maintenance, we also talked about the routine maintenance, including performing periodical checks and system run efficiency, including cleaning and software monitoring, but also ensuring that repair and replacement of fault component is done. And other key maintenance activities, we said, including solar panel cleaning, involving removing dust and bad droppings and other debris on the system, but also talked about regular cleaning to prevent dust building that can reduce panel efficiency, and then keep the inverter monitor system updated for better performance, but also the issue of component replacement. I think that's where we stopped yesterday. Prof. Karume, what is the next move after this? Okay, apparently Prof. Karume is not let me then continue to where we stopped yesterday. Where we stepped on.
Prof. Majaliwa, you should continue with geothermal energy. You should continue with geothermal energy.
Yeah, let me.
And I will take over from there to discuss biogas.
So I want to share. I think Prof. Karume should be having issues with his internet.
Don't you get me, Prof. Majaliwa?
No, now I can get you. I think at
least at certain time you should continue from there.
But now I can see. I can take you. I can get you.
To take biogas, geothermal, and after geothermal, I will proceed with biogas.
So in terms of geothermal, yesterday, the other day, I think 2 days ago, we discussed the different types of geothermal, which include the geothermal power plant for high temperature system, the direct system, the direct use system with low temperature system, but also the geothermal heat pump with ground source heat pump. So as we also said for the previous energy system, we still need to do a site selection, a site assessment of feasibility, where we assess the resource available in terms of the temperatures from the stream, the steam coming out of the site, but also looking at geological and environmental studies, because we still need to see the environmental impact assessment, but also the energy demand for this particular site, but also the part of economics, because we don't want to invest money and you don't get any benefits from it. Now, the different components of the geothermal system include the production well, that is basically from underground, and where you actually extract the hot water, and the stream coming, the stream coming of it. You try to extract the temperature to exploit the temperature from those steams to generate the heat you require. for use. And if you really need to transform it into electricity, you put the required equipment, the conversion device, to make sure that the conversion is done. But you also have the different injection wells, because you have to drill where you are going to extract water from, but also where you are going to re-inject the water. You also have the piping and valve system, because if water is extracted and it has to be transported for heat extraction to another place, then you need a lot of piping and valves to tie the pipes, because you can't have, if you have a 50 meter or 100 meter distance to be covered, then you need to have several pipes, and that will require several valves also to tie the different pipes. So as I said, you also need a heat exchanger, but this will be the one to assist you to transfer the heat from the steam to a secondary system, which will actually assist probably to create the rotation necessary and provide the required energy through the turbines and generators attached to the system. Then you have a cooling system, because once you have extracted the heat, the fluid, when it loses its temperature, it actually goes into a liquid form, and that liquid form needs to be transferred again back or re-injected into the heart. And then you have the control and monitoring system, and this is basically to control the pressure of the steam and the temperature of the steam, but also the flow rate of the steams. And this also should, in terms of flow rate, is how energy is flowing from one place to the other. So in terms of design, we need to look at the system, the sustainability of the system, but also the temperature and pressure of the steam coming from the geothermal source, but also we need to put up mechanism for dealing with corrosion. I think one person the other 3 days ago asked this question. So we need to put in place a mechanism for dealing with corrosion. But also, if we want to expand on the production unit, then we need to look at aspect of scaling up. Scaling up in terms of production, but looking at the demand on the other side. Environmental conditions and protection is very, very important, as we say, because of the emission coming from the stream, but also contamination, the risk of contamination we are likely to create by putting the system. As we remember, as the turbine or the metal where the case where the turbines are located start getting corrosion, then some of these materials end up into the well, and we need to deal with that groundwater contamination and try to minimize it. So the other aspect is the issue of system efficiency, but also maintaining that efficiency. The flow, depending on the temperature of the reservoir, so the energy coming out of it as output may also be affected. So we need to make sure that we optimize the energy which is coming off this system. That means minimizing the losses generated across the system. So in terms of maintenance, as for the previous energy system, we need regular inspection we need to clean wherever we want to clean and then monitor the system performance for the different components. We need to think of repairs where we have faults, especially in terms of turbine, but also in terms of the generator used, but also looking at the leaks. If there is any leaks on the piping or in the valves, but also tightening some of the bolts to make sure that the system is really closed. So we need to remove corrosion in pipes and casing to prevent leaks and structure failure. We also need to make sure that the pressure and the temperature remain within the limit of the output you actually need. And then check alignment and balances of turbine as we discuss it for the hydro and for wind. So we need to make sure that the turbines are actually very, very stable. So in terms of safety, we need to look at for every time that we want to do maintenance, of course, for any electrical system, you need to shut down the system. That is the must. Where insulation is important, kindly put it, making sure that during the maintenance, you have to be, or the regular check, you have to be wearing protective gears to prevent electrical shock, but also making sure that all the batteries are well maintained. They are not put on the floor. If they are put on the floor, then they should be either a piece of timber raising up the battery, but also avoiding all small mistakes which will actually take us to short circuit connections. So this is what we had planned for geothermal, and therefore we have concluded with chapter module 4, and I will request Professor Karume to go to the next section. Prof. Karume.
Yes, Prof. Majaliwa. Thank you so
much. Will
go
straight to the economics, or you want first to go into the biogas?
Biogas, because you will take over from biogas to economics, and conclude by the economics.
And then so I need some minutes to download what you shared. Just bear with me for 1 or 2 minutes.
And as you are preparing for sharing the screen, people have realized, but aren't have realized that at the end of each module, we have a supporting material. Supporting materials, they may find in the supporting material some references, as well as some YouTube or videos which can help for a good understanding of the course.
No, I'm not online. Not online. So let me send this one to Runyararo to share, because my system seems to be too old to share. Just a minute. Yes, Jolene, can you check in your system and download that one and share? Hello, Jolene. Just a few minutes, I think I'll be there. I've already sent to Jolene, but apparently. Let me get another way. I've sent to you the presentation on biogas. Prof. Karum just shared.
Okay.
Is it possible to download it and share with everyone?
Let me download. I show on the screen.
Yes, please.
Okay.
I stop sharing.
Yes.
Okay, thank you, Jolly.
Are you seeing it well?
Yes, I've seen it. So let me proceed.
Okay.
Once again, sorry, participant, because we had this small issue which has been solved. But participants may wonder throughout our 3 days presentations, we are all the time coming back to hydro, solar, wind, geothermal, and the biomass. And they may wonder, biogas is not a renewable source of energy. This is the question we are going to answer. For sure, biogas is a renewable source of energy, but question is still if it's a clean energy or not. So, you know, some people may think that biomass is a clean source of energy, and others may think that it's not. And still discussions are going on. But for us, we can consider by the time being that biomass is a renewable source of energy, but not a clean source of energy. Why? Because we are going to see right now, this is the reason we have, we saw that we should present biogas as a source of energy apart from the other sources which we are considered before. So biogas, so we can go ahead. Anaerobic biogas, we are going to proceed the same way. What is biogas? How does it work? What are advantages and disadvantages of biogas? So anaerobic digestion, which we are going to abbreviate all the time as AD, is a conversion of feedstock, which is any organic non-woody material by a microorganism in the absence of oxygen. And this is transformed into biogas and digested. So when we get feedstock material, any organic material, which is non-woody material, we take it through fermentation. At the end of the day, we are going to obtain biogas and digest it. these are products which will come out of anaerobic digestion. So it's a natural process and is well understood by mankind, because this technology has been used for a long time, more than a century. So it's a well-known technology, and it has been used to harness energy for many years, more than 1 century. So livestock production system, for example, this biogas had a number of benefits. The main benefit is producing biogas, and as well as we are going to produce also digestate. So the biogas systems are the advantage that not only it produces energy, but in addition, it produces, let's say, fertilizers in form of digestate. So biogas system also can go through a maintenance principles. Why do we have biomass as a very good system? Because it gives a number of advantages. The first one is provision of supplemental renewable energy. As I was saying, the gas out of biogas can be used for energy production, either directly for heat production or for electricity production. But in addition, we have also as advantage. So it comes out of odor. So odor reduction is one of advantage of biogas. Reduction of emission of greenhouse gases. Though biogas system produces a number of greenhouse gases, but the amount of gas produced is less than what can be produced when we are using landfill systems. That is a big question we are trying today to discuss. And other advantages, we have a control of pathogen, we have a waste biostabilization, and finally, we have nitrates which are preserved. And in addition, what do we have? We have we transform these material into different forms. So biogas is a byproduct of the anaerobic. Whenever I'm talking with anaerobic, people should understand that it's without oxygen, a system which is free oxygen. It's, as I was saying, it's a product of the anaerobic breakdown of organic matter. When I'm talking about organic matter, it may be from animal waste, or it may be from crop waste. The organic matter could be any of a number of material from farm, from cities as waste, from animal manure, or as agricultural waste. The most important component in biogas is methane production, which is a flammable gas that can be used to produce heat through a furnace or for cooking using equipment which is going to heat up. In addition, we can also have it as energy to fuel a system. Biogas also contains not only methane, but it contains, in addition, carbon dioxide and a small amount of hydrogen sulfide, and in addition, we have nitrogen and water vapor. So when we consider these gases which are coming out of biogas, let's say methane, in addition, we have carbon dioxide, we have hydrogen sulfide, and we have also water vapor. People can realize that all these are greenhouse gases. This is the reason why people consider biogas as not a clean energy, because it produces a big amount, let's say a big amount compared to the other 5 systems we have been dealing with, a big amount of greenhouse gases. But when you consider it as a system which can transform waste, people sometimes they can say it can also be considered as a clean source of energy. But for us, in terms of greenhouse gases, we can see that biogas is not a clean source of energy. So the table we are seeing is clearly showing the percentage of the different gases which are coming out of biogas. So the first one is methane. Methane comes in proportion of 50 to 60%. We have carbon dioxide between 20 and 50%. We have nitrogen less than 1%. We have hydrogen less than 1%. We have ammonia, which is also less than 1%. And finally, we can have some hydrogen sulfide, which is coming less than 1%. So the last 4 gases, they are coming in a very, very little amount, but we have a big share of carbon dioxide and methane, which can go up to 80%. This is the reason why we always consider biogas as not being a clean source of energy. So how it process? The anaerobic digester, first of all, to make it work, we need to get manure or other organic waste. Other organic waste can be used. So we have manure or other possible biomass feedstock, which are going to be inserted into a large sealed airless container. And in that container, we have, as it's an oxygen-free environment, bacteria will produce biogas. So in most digesters, the container will be heated. Why do we heat it? To accelerate the process. And people will realize that if that outside temperature so
I'm not.
sorry.
I had lost you a bit, but it's okay. You can continue.
So the content will be heated to accelerate the process. The produced biogas can be used to generate heat or electricity. But as people will realize, gas coming out of biogas, it's low pressure gas. And to produce electricity, this gas has to go through another process to make it high pressure gas so that it can be considered in a generator to produce electricity. The electricity that is generated through the gas engine can be either supplied to the electricity grid or it can be used for own consumption. Remember, when we are talking about as a renewable energy, we said additional energy, the energy generated which is not used on site, on farm, or on community levels can be injected to the grid for getting some money by interconnecting energy produced to the main grid. So the heat can be used for the digester with the surplus, which can be sold also for heating residual houses or some commercial building. So we retain that when we produce biogas, the addition part can be directly used for heating buildings, commercial buildings, or for heating households, or we can use the additional heat, the additional biogas to produce electricity and send it to the grid. So in summary, how do we work with biogas? First of all, we start by collecting feedstock. We collect feedstock as organic waste and as animal manure, and we feed the system. We feed the system the first chamber, the chamber which will receive the feedstock. In addition, if we don't have manure, animal waste, we can also use any municipal sewage or waste, which can be feed inside. As long as it's organic matter, it's possible to produce some methane out of it by fermentation in an oxygen-free environment. Secondly, after collecting feedstock, we have the second step is to proceed to fermentation. We ferment the material using bacteria, which is going to break down organic matter in a oxygen-free environment. So this is done inside the digester. After this fermentation, we have gas which is produced. The gas which is produced mainly methane and CO2, but for us methane is the useful gas which will be released as a microorganism. They decompose the waste. The end of the system is a gas which is produced should be utilized. So the gas we produce can be used for energy production, and energy production in terms of heat or in terms of electricity. So how do we design it? Remember, we are following the same process. Is first of all, what is a system? How does it operate? And now we are at the design and the maintenance level, and we will end up by seeing is it economic or not. So design. The microbial process of AD requires careful management to maximize its potential. So we have several design which can be used, but for this course, I'm going to emphasize more on which is built using concrete, using cement, bricks, or other material, building material. But I'm going also to say that today, and we have been using it for a long time at the university, biogas, which is using plastic material. It is more convenient to transport and so on. So we have a number of design, and each design has its own cost for implementation and return varying from efficiency. So the one we are going to consider as for biogas, it includes, first of all, operation temperatures. The second one, we have to see what is the level of moisture. Sadly, we are going to consider the continuous or the batch system. We are going also to look at either a single or a double or a multiple digester systems, or finally we are going to look at vertical or horizontal tank layout. So the tank can be horizontal or it can be vertical. So as I was saying, we can have, when it's plastic, the tank is most of the time it's a horizontal tank. When it's built out of cement and sand as bricks, generally the tank is vertical. So let's see what are benefits of what are benefits for this biogas. So the table is showing 4 columns. The column for farmers, what is the benefit for farmers, what are benefits for food processors, what can be benefit for local community, what can be the benefit for the environment, and what can be the benefit for the government. Those are columns we are going to consider. So let's start by farmers. The farmer is going to get a profit in terms of digester, which is going to be used as a fertilizer, and energy, which can be in terms of heat or in terms of electricity. So for food processors, we have food waste, which are removed. Instead of taking them to a landfill, we just get the food waste, which is going to be the input for biogas. For local communities are going to benefit for less smell. Remember, the system has a benefit of reducing the level of odor. So when you take waste in landfill, it produces a lot of smell. But with this system, we reduce the level of smell. So what's the benefit for the environment? The benefit, we have less nitrate pollution. Landfill produces a lot of nitrate, but we have seen that when we are using biogas, the level of nitrate is less than 1%. And finally, for the government, is going to benefit by reducing the number or the size of landfill, because now these wastes are going to be transformed in terms of energy. So again, for farmers, is going to get support. And for food processors, we have cheap option for waste management. This is a cheaper option when it comes to waste management. So the food processor is going just to give out the waste, and someone will take care of it, and do not spend money for processing this waste. So for local community, is going to have renewable energy, which is locally produced in terms of heat, in terms of electricity. For the environment, we have the reduction of greenhouse gases, which will be emitted into atmosphere, and thus reducing climate change effect. And for the government, we have nitrate directive, the directive, which is going to be more constrained, because the amount of nitrate will be very low. So going to benefit, the table also showed that for farmers, we have a small amount of nitrate which will be going out, and thus the farmers will not be having a high level of taxes. For the food processor, is going to have a very good image in terms of waste management. For the environment, what we have is a supply of heat locally produced or electricity locally produced. For the environment, we have a landfill which is going to be reduced or simply will not be there. And for the government, we have a renewable source of energy and a very good technique for waste management. So what do we have for, again, for farmers? We have a diversification of source of energy, because not only he can rely for solar, wind, biogas, biomass, or hydro. And if they are not available, at least you can rely on this source of energy from biomass. So we have diversification of source of energy for local communities. We have clean environment. For environment itself, it's going to benefit to replace and maintenance of way of this. So for the government, what do we have as a benefit? We can have also biofuel, which will be produced, and the biofuels can be used in transportation. So as you can see, we have a number of benefits which are coming out of biomass, not only for the farmer, not only for the food processor, for the community, but also for the environment, or for the environment at large, as well as for the government. So now let's see how it is, how we design this biogas system. The biogas system has two chambers. The first chambers 1 and chambers 2. The one is made to receive waste which are going to be deposited for this inlet, which is at left, and the outlet, which is at right. Outlet is to collect digester after we have removed the energy, the methane content inside that. So the first chamber is a chamber for fermentation. The second chamber is the chamber for gas storage. And we have a cover to make sure that no oxygen is going in. So the system will work perfectly because it's an oxygen anaerobic system, which will be able to produce bacteria which is going to transform this waste. So main parts of biogas, we have the inlet at left, the outlet at right for digester collection. We have the fermentation chamber, and we have at right the gas storage chamber, and all the system is covered, sealed to avoid oxygen coming in. Go ahead, please. Jolie, can you move? This, I've put it just
I
a
move
figure.
again, or...
Move again.
Is it okay where I am?
Move. Okay. So we are looking at this digester, and let us look at a cross section of a digester. If we look at the cross section, what do we have? We have just for this type of biogas, we have this include a organic waste chamber, which is used for fermentation, which we call a fermentation chamber, where anaerobic digestion is taking place. We have the second chamber in the gas storage section, and we have a outlet and for the digester collection. So the fermentation chamber is maintained to make sure that fermentation is going very well at a high temperature, because when the temperature is high and the pressure is high, we produce a very good amount of gas, of methane gas. So this temperature and the pressure can make the process more smooth and more easy to go. And at the end of the day, after fermentation, gas is produced. So after the gas is produced, and as long as you input waste in the inlet, what is going to take place? The material, the waste is going to move to the other chamber, the storage gas chamber, and the manure or the waste after getting the gas, the gas content can be taken from the outlet. So when you get at the outlet level the treated waste, you can now use this as a fertilizer. So not only you get energy in terms of gas, which can be used as heat or electricity, but in addition also you get manure or fertilizer. So when you are computing the gas which will come out of your digester, you can make a number of assumptions. And among those assumptions, you can, for instance, say the volume of the digester is assumed based on the retention time and daily feedstock input. The other assumption which can be made, you can say, for instance, the digester is assumed to have a cylindrical shape with down shape on top, but the shape is not always cylindrical. You can have also a square or a rectangle shape, but to compute the volume, we can make that assumption. So you can make two more assumptions that the hydraulic chamber volume is considered equals to the daily feedstock input. And finally, hydraulic chamber is considered as a rectangular tank. So those are assumptions you can make when you want to compute the energy, the volume of gas you'll get out of your biogas. So what can go wrong when you are using a digester? We are here almost talking on operation, and we'll talk also about maintenance. So what can be wrong? And this is the big problem with digester. So the digester problem come mainly when the digester's pH drops too low. So when the pH drops very low, it becomes a big problem for digester. And this in general is coming when the acid forming bacteria grow much faster than methane forming. And when is so, you don't have the waste, the bacteria is not able to easily transform waste, and you need to stop the system and to start afresh the system. And this process is too costly because you have to take time first to remove, and during that time you don't produce energy. So this can reduce the pH to an unfavorable level for methane forming. And when methane forming bacteria are not enough, so what we have at the end of the day is the activity of metazogen is slowed down, and the system will not work properly. So people have to put more attention to this problem. So when you are you are using your digester, you have to check on the pH, the chamber, the fermentation chamber. So what can be the role for maintenance of the biogas system? So we maintain, as we did for the other renewable sort of energy, we maintain the biogas plant to make sure that we don't reduce the efficiency of the system. And the maintenance, most of the time, is about carrying out some minor repairs or to change faulty equipment. So the good thing, you don't have a number of spares in movement. So to repair is almost the time very simple to do. But the big problem is when pH is going down. So also we do the maintenance of this to make sure that the annual cost of operating biogas plant is low. Because if you don't maintain, at the end of the day, you have a breakdown of the system and it's going to be more costly. So this graph is showing different costs. You can move to the next slide, please. This figure is showing different costs which are coming when operating a biogas plant. So you can realize that the first one is purchase of material. The material you use for making the gas plant, it can take 10% of the whole budget. So treatment of digester can take 1%. We have personnel costs, which can be up to 16%. We have assurance, which can take 4%. We have electricity, which can take 9% when you are selling electricity. We have maintenance of the engine and other equipment, which is the most important part, which can take 33%. We have, let's say, other courses, and at the end of the day, the most costly part is maintenance of the engine and other equipment. That's why we have to pay attention to not break the engine, because it's a most costly part of the system. So what are benefits of rigorous maintenance of this biogas plant? The first benefit we can have is by doing regular maintenance of the biogas plant is mainly for prevention and technical and avoiding technical failure. Because when we have technical failure, it's going to be too costly. So the second advantage is to avoid the problem of the processing system. Third, we have as a benefit of carrying out maintenance, you increase the life cycle of the equipment. So by doing maintenance, you prevent at the same time accident, and you operate safely your plant. And this is not only you create a safe environment for workers and a safe environment for the environment itself. And finally, what we have as benefit, you produce continuously biogas, and you don't have a breakdown. So how to maintain biogas? To maintain biogas, we said we have to do regular maintenance, which is routine maintenance. So you can do it by interval time. You ensure, for instance, after, let's say, a certain amount of gas release, you do maintenance. Or you can say after a given time, let's say 100 hours, 2,000 hours, you just do a regular maintenance. And that one is going to be a routine maintenance. So we have also, when you are carrying maintenance of the equipment, you have to identify problems, and if there is a equipment to replace, you just replace it. You have to keep spares well functioning, and all the equipment should be visited all the time to make sure that they are properly working. And you have to find a supplier or a repairer which is available, because sometimes you are not able to carry it alone. You need to find someone who can do it, which is specialized in repair. So in the area, you should identify someone who is expert in maintaining this system when it comes to serious problem. So, so what to do in case of failure? You don't have to do much. You have two possibilities. The first possibility is to consult the go ahead. Yes, I was saying what do you have to do in case we have a technical failure. We need to do two things. The first thing is you just consult the instructions, because when they give you the install a biogas system at your farm, you should also having at the same time a book of instruction. So you can refer yourselves to these instruction books and see if you have some things to do. And if you are not able to do something yourself, the second thing you have to do is to go and find someone who is specialized in maintaining or repairing biogas systems. So how can we reduce the maintenance cost? So to reduce the maintenance cost, you have first of all to consider working very well with your digester tank, because that is the main part of your system. So, you can have some tools which are very simple tools which can help you to clean up your digester chamber. And remember, we have two chambers. We have a fermentation chamber and the gas storage chamber, which should be maintained properly. So the most thing to do is to be able, when there is a problem, you remove, let's say, material which has been stored in your digester and which cannot be transformed by bacteria, which is transforming waste. So that is going to be the big things to do, because as we are going to see, you just feed your inlet and you take out at your outlet, you are going to take out the digester. It's a self-cleaning process, but sometimes you have to remove no digestible residues. because when you are feeding your digester, you feed it with different material, and some materials can be not digestible. So those one at the end of the day, when there is inside a big amount, the efficiency is going to be low, and you need to remove these non digestible material. So the process, go ahead. What are advantages of using? Go to advantages of using biogas. It helps high quality to obtain high quality separation of contaminants. So what are advantages? As we said, first of all, you obtain manure which is not contaminated because it went through a high temperature process. That's the first advantage. And we have also manure which cannot, which is odor free, or it's giving a small amount of odors. So you have also as advantage, we obtain different types of waste which can be used for fertilization of your field. And also we can take the minimum amount of digester which you create at the end of the process. But because remember, when you are using a biogas, not only you produce energy, but in addition also you are doing a waste management process. So if you input a big amount of waste, at the end of the process, you obtain a very small amount of waste. The rest of waste has been transformed in energy. And finally, as an advantage, you have you meet the standard of no visible contaminants because the process goes through high temperature. So what are challenges and the limitations of using biogas? The first challenge is high initial investment cost. But today people are working on this to reduce that high investment cost. Though it's still high because even if you are using a plastic system, as I was saying, a plastic system which is more flexible, is more cheap and more practical, you still need to pay something around $400 to obtain the system, the plant for biogas production. So that's still the big limitation for biogas. You need to have enough money to invest for to obtain this system. Secondly, we have as a challenge technical knowledge which is required, because we have seen that to maintain a biogas there is need to have knowledge, and sometimes people outside there in rural areas or on farm, they don't have knowledge for maintenance or for designing this system. Third, as challenge, what do we have? We have limited awareness. People don't know, a number of people don't know that biogas can have a big advantage by creating not only energy, but in addition, you have quality fertilizer. So we need to make awareness of people so that they can adopt this system. And The last one, we have a feedstock supply issue. That's why when we are operating at a community level, when it's about communities in rural areas, the way to do it is to sensitize people to bring together their manure for energy production, and at the end of the process, they can have their waste, of course, in a reduced quantity to be taken to their field for fertilization. So how to go, how can we go out of these challenges? How can we go out of this limitation? And those are possible solutions. The solution can be either government can give some subsidies, or we have to carry out some awareness campaign so that people can be aware of this technology. And the government government subsidies can help to reduce this high investment cost. So, in conclusions, we can underline that biogas is a sustainable energy solution. Not only it gives you energy, but in addition, it can give you a high quality manure, which can be again used for agriculture production. Two, the people, that will be the way forward. We need to do more research in infrastructure as well as in policy making, or in policy to be adopted to make sure that biogas use is biogas adoption is extended to a big number of people. And finally, we need to integrate biogas in the circular economy, because biogas can not only allow to produce gas which can be used on the farm, but the additional gas can be used to heat houses or to heat commercial places. So this is mainly what I wanted to present for biogas, so people will know at the end of the day that biogas, it's a very good renewable source of energy, but still discussions are there. Is it a clean source of energy? For us, we can consider it that it's not a clean source of energy, given the number and the amount of greenhouse gases which are coming out of the system. Thank you for your attention. Majaliwa, can you take over to present the economics of renewable energy? Prof. Majaliwa.
Thank you, Prof. Karume. So we can finalize now with the last component. I hope you can, people can see it already on their screen.
Yes.
Yeah, so just 1 minute to assist me to. So basically, this is the economics part of the renewable energy. Of course, it's very important that we address the issue of energy needs or demand at our household or in the communities, within the society. But also very important to check the economic aspect of the units we actually put or establish within our households in the different agricultural value chains to make sure that they're economically viable. So, of course, we already discussed this. We know that several applications of renewable energy in agri-food systems. We talked about the solar-powered irrigation system. We talked about the greenhouse. We talked about domestic supply in the transformation. We need them for milling. We need them for drying. We need them for cooling and refrigeration. But in the distribution system, we need them in the transport system. We need them still in the cooling chain and other applications, including precision farming. So, but the biggest aspect here is to be able to assess the cost associated with our investment in terms of technologies or the solar types or combination of solar types. Then the cost of operations, and we see how much saving in terms of energy, but also in terms of resources we have accumulated over time. So we just want to give you some examples to show how viable some of these systems are. If you take a solar system of 1 or 5 kilowatts, the cost is approximately 5,000 during installation. And then you probably have to spend $500 for over 10 years. So if you look at it in terms of annual benefit compared to other system, then you have around $700 saving on electricity. And this represents around, for 7 years, close to $5,000. And in terms of lifetime saving for the 20 years, we get more than the $7,000. If you look at your cost the other side, we really see that we have a positive internal return rate. Apart from the monetary value, there are other benefits. In terms of reliability, the solar panel is very stable. The only problem, of course, is when the system is cloudy. But if you have some good saving, if you manage to save to charge your battery, you will still use it. In terms of health, there is no pollution in terms of direct pollution on human beings, unless after the lifetime when we want to decommission the system, that we need to do some recycling. If you compare it, for example, for paraffin and diesel, of course, there is no pollution. Then, of course, during the installation, you can create some jobs. Even during maintenance, you can still create some jobs. And if the system is also put on the grid, then we know we can actually serve other locations than where energy is being produced from. If you look at wind energy, if you have a turbine of 2 megawatts, in terms of cost, that is approximately 3.5 million including installation, cost and installation. In terms of maintenance, you need approximately $50,000 annually. But in terms of benefit, the annual electricity production is around 6,000 megawatt hour. And in terms of saving, if you have, you are selling a kilowatt hour at $0.1, you will get approximately $600,000 in terms of annual savings. And if you really want to go into the lower pay rate of 0.05, then you still have $300,000 in terms of saving. So you actually recover your cost of installation and investment just after 6 years. And the lifetime benefit is around 12 million if you are going to a rate of 0.05 kilowatt per kilowatt hour. But if you go to a rate of 0.1 dollar per kilowatt hour, but if you go for 0.05, you still have 6 million. You are very far away from what you have invested as benefit, maybe two times, around 2 times. So if you take a geothermal and you consider 20 megawatt drilling and exploration costs you $40 million, the construction approximately $60 million, and the annual operation and maintenance will cost around $4 million. In terms of annual electricity production, you can have 160,000 megawatt hour. And if you sell at $0.07 per kilowatt hour, you have an annual revenue of $12.2 million. And the payback is approximately 10 years. So if you look at the lifetime benefit at 30 years, is almost 10 times the cost of your drilling, or 3 times the cost of exploration, drilling, and construction. In terms of internal rate of return, even if you put it at 10%, you'll still have benefits. Even if you put the cost of electricity at 0.05 per kilowatt hour, you still have a lot of benefits. So, but the challenge, of course, is you need to pay a lot of money at the beginning. Then also, especially for geothermal, when the resources are depleting, but also the geological risk when you are re-injecting some of this fluid into the earth. So that can create a number of challenges, environmental challenges. But if it is done properly, gradual injection, certainly this will not be a big problem. If you look at the biogas, as Prof. Karume said, which is actually spreading all over the continent now. If you look at the small-scale digesters, they can go to $300 to $1,500. I know for in Kenya, this can actually be even lower than that. If you look at the medium to large-scale digesters, you can have them at 5,000 to 50,000 or more. But the operation cost, if you include the operation cost and the feeding the digester and paying the local labor, you don't spend basically too much money. So in terms of economic benefit, of course, we provide relatively clean cooking alternative compared to cooking stove. then we can also increase our agricultural productivity by using the byproduct. We can have these environmental and health benefit by reducing the indoor air pollution if you are looking at the three stones, but also decreasing deforestation and whatever carbon emission related to it, basically by providing electricity, not in forms of fuel wood. So, though biogas, as Prof said, still contribute to emissions, but their emission is less than the one which will be coming from deforestation. Now, in terms of income, of course, it will still provide some relative revenue to the farmers by actually providing energy to the household. The waste coming from the digester can actually be marketed and sold as biofertilizer. And also installation, maintenance, operations, all those will provide opportunities for people to get jobs. So this is basically the end of our training today. I want to thank again Professor Karume for assisting developing this material. Prof. Karume has a background as myself to attend the technical school, so we have been in the same technical school. For him, he has been doing electricity. I did mechanics, and then all of us are physicists. 5 years of physics, and Prof. Karume has a doctorate in physics. I went into environment and then agriculture. So if there are questions, you are welcome.
Yes, Majaliwa, let me just add a word on what you have been saying. Sometimes also when you are doing some analysis on a system, people should understand that we have two ways of seeing things. You can do a analysis and you can do also economics analysis. So a system cannot sometimes be financially good, financially, let's say, give benefits in terms of money as finances, but the system gives other benefits outside money. Let's say benefit in terms of environment, benefit in terms of health, benefit in terms of environment, and so on. So people will not only consider the finance part of the analysis, but they should consider the economics analysis as a whole. I wanted to add that. Thank you, Prof. Majaliwa.
Yeah, so now if there are any questions, Jolene, kindly assist us to check if there are questions. We are ready to give our contribution to make sure that people understand what we have been discussing. Yes, Jolene, the ball is on your side.
Colleagues, should you have any questions, please put them on the chat or raise your hand so that we can have the. Oh, I can see some questions here. I can just read some questions. The economics of renewable energy is the icing on the cake for me. Oh, it's just a comment. It is a well thought out. It's well thought out. So it's just a comment from
Thank you,
colleagues. Yeah. So colleagues, if you have a question, please just unmute yourself. Okay, let me read this one. This one is, I would like to sincerely thank Professor Kacho for the high quality, particularly enriching presentation in the light of the points discussed. Could you clarify whether the digest?
Yeah, because I want to work on it for the weekend.
Oh, the thing is, it is long, so I have to find ways of increasing. No, but maybe I can ask the person to ask. Kabuye.
Yeah, just ask a person to ask, yes. Go ahead.
Dominic, Aganze, Mulume, please ask your question. Okay, let me try to read. So it says, I would like to sincerely thank Professor Kachi for the high quality and particularly enriching presentation. In light of the points discussed, could you please clarify whether the digested from anaerobic digestion has optimal physiochemical characteristics for effective use in agriculture?
Yes, I have to confirm it. Remember, I was saying the good thing with biogas, because the waste is going through a high temperature process, at the end of the day, the waste collected and which is going to be used in agriculture as fertilizer is going to be free of grains, because you know when a cow is eating, is grazing, it can graze some grains, which if you use dumped from it can grow in the field. But when it passes through the biogas process, it is killed, and at the end of the day, you have a product which are on as well as chemical biology is concerned, products which are which is recommendable.
Okay, the second says, I would like also to know what factors influence the calorific value of biogas and how it can be optimized.
Come again?
He says he would like to know the factors which influence the calorific value of biogas and how it can be optimized.
Two factors. The first factor is the material you feed in. So when you have different materials, different types of waste, you have also different level of gas, of methane gas produced, and the level of calorie emitted. That's one. The second factor is temperature, outside temperature at which the system is operating. Remember, we said when the temperature is high outside, it can accelerate the anaerobic process. So those are mainly the two factors which can influence the gas which are coming out of biogas.
Thank you. Let me look for the last question. He said, could you guide us on how to adjust the pH of the digester to optimize biogas production? Professor, did you get the question?
Please come again. Oh, Majalo also can take it. It's okay. Yes, come again.
Oh. He said, could you guide us on how to adjust the pH of the digester to optimize biogas production? Professor Majaliwa. I don't know whether I'm the one who is offline or.
I think that is
Professor Kacho, could you respond to the question? Meanwhile, I would request all of us to respond to the evaluation form which I've just posted on the chat. Could all of us respond to the evaluation form which I've posted on the chat? This is the end of training evaluation, and the link is given there. I am trying to get hold of Professor Kacho and Professor Majaliwa to give us a response to that last question. And also there's another question which was brought. Let me see, I think maybe it's just a matter of internet challenges which we are having. Professor Majaliwa, can you hear us?
Yes, go ahead, Jolene. What is also the question? Sorry, you know I'm preparing for another meeting. But just what was the question?
Could you guide us on how to adjust the pH of the digester to optimize biogas production?
But generally, the biogas production is effective when the pH is in the range of 6.5 to 7.5. So if you are under those values or above those values, certainly this can be a problem. So there should be mechanism for making sure that the pH is within those values. I believe that the addition and the checking the values of the pH of the materials we actually introducing in the biodigester is very, very key in controlling the range of the pH in the digester.
Yes, Majaliwa, I think people should know that the pH which is recommended for maximizing, for optimizing the process should be around 7. So 7, which is almost neutral. It should not be either acidic or too basic. So people should make sure that the pH is around 7. This is a pH which is recommended for optimizing the digestion, the digestion process, the fermentation process.
Thank you, professors. There's one last question. Samia says, how can I store biogas, converting it to electricity?
I think for conversion, for conserving. Is it conserving? Are you saying how? Yes. Yeah. So they are these containers which can assist to do that. So we can extract the gas from the biodigester because it's on top. So this one can be transferred to these containers which are used as package for commercial use of some of those gases for as fuel. That's a simple process.
Thank you so much, Professor Majaliwa, for that comment and response. I would like to sincerely thank Professor Kasho Karum and Professor Majaliwa for taking us through the training, and I know it has been very informative to all of us. I would like to inform you that you can actually go to our YouTube channel, Forum Network, to actually revisit some of these presentations. We shall also again send you the PowerPoint presentations for your further reference. Make sure that you have registered so that we can capture your email. We kindly request you to fill in our evaluation form. It will not take much of your time, just take some few minutes to fill in so that we know how you felt when you are attending this course. So areas where you think we were great, areas where we need improvement, we need feedback from you. So thank you, everyone. Thank you for being part of this training, and let me wish you a great weekend. See you next time in another training.
Yeah, thank you very much. Okay, bye.
Bye, bye, thank you.
Ok, Karoum, est-ce qu'on peut discuter dans quelques minutes?
Sans problème.
Comment est la situation chez